there, let's talk about chemical reactions. The definition of a chemical reaction is a chemical change where chemical bonds are broken and reformed. You always start with reactants, and those reactants undergo chemical change and turn into products that are a different thing, a different compound than what you started with. Old bonds are broken in the reactants. It's kind of like Legos, like maybe you make a castle out of Legos. Then you take your castle apart, rearrange it, and you make a robot. It's kind of what happens in a chemical reaction, except for instead of Legos, you have atoms. You are breaking the bonds that existed, and you're rearranging those atoms in a new way, which makes a new substance. Just a reminder that a chemical change, as opposed to a physical change, is one in which a new substance is made with new properties. In a physical change, you wouldn't alter what the substance's identity actually is. Like, for example, a physical change might be water evaporating. You're not changing the fact that it's water, you're just changing its physical state from a liquid to a gas. It's still water, as opposed to a chemical change where it would actually react, and if water was reacting, it would become something different, maybe hydrogen gas and oxygen gas. We write chemical equations to show what happens in a chemical reaction. It always looks like this, where we have reactants and an arrow to make what we end up with our products. We use a plus sign as a separator. If you have more than one reactant or more than one product, you can separate them using a plus sign. The arrow means yields or forms. An arrow with a triangle over top of it means that heat is required for that reaction to occur. An arrow that has kind of a lightning boltish looking thing on top of it means that electricity or light is required. So something like photosynthesis maybe that requires light. You don't ever have to draw it that fancy. Usually it just looks like kind of a squiggle almost, like that. That means electricity or light is required for that reaction to occur. If you see a double-sided single arrow, that means that the reaction is reversible. It is taking place in both directions at the same time. And actually, most reactions are like this, where they're going back and forth. If you see a parenthesis S next to one of your reactants or products, that means it is a solid. If there's an L in parentheses, that means it is a liquid. And if you see a G for gas, if you see an up arrow next to a product, that means a gas is released. It is never shown next to a reactant, only a product. A down arrow next to a product shows that a precipitate is formed, and PPT is the abbreviation for precipitate. A precipitate is something that is not soluble in water, so think like sand. And when you form one of those, you will see it kind of fall down to the bottom of your test tube. So think about that lab you did at the beginning of the year where you took 2 clear colorless solutions that you made, and when you dumped them together, you made this yellow solid that floated to the bottom of your test tube. That was a precipitate. And again, that's abbreviated PPT. And then finally, if you see in parentheses AQ next to a reactant or a product, that indicates that it is dissolved in water, and the term for that is aqueous. Okay, so I want you to take a minute here to try to write the equation for this reaction right here. When isopropyl alcohol is exposed to enough heat, it reacts with oxygen to form carbon dioxide and water. So go ahead and pause it, see if you can write the equation with your reactants and your products, and then any of the information that you can add about those things, and then unpause and compare it to what I have. Okay, this is what I have. Isopropyl alcohol is a reactant, C3H8O, and it's an alcohol. This one happens to be a liquid. Maybe you didn't know that part, but I have an L there, and I always use like kind of a lowercase cursive L for mine, so it doesn't look like an I. And then I have a plus sign to separate that from the other reactant, which is oxygen. And that is a gas. I know that's a gas at normal room temperature and pressure. And then it says it when it's exposed to enough heat. So I have a triangle over my arrow. And then it says to form, which means now I have my products. Carbon dioxide is one of them. And I showed an up arrow because it's a gas that's produced. It's a product. And water, which is a liquid. Now, if you didn't draw an arrow and instead you used a G for gas, that is great. You can totally do that instead. But what you can't do is use an arrow over here for oxygen because it's not a product. So you can only use those up and down arrows on the product side, which is your right-hand side. Couple more things to point out here. If you were going to balance this chemical equation, we can do that by adding coefficients. So I'm going to use mine in red. I would start with my carbon, so I would make that 3. And then I would go to my hydrogens. So I have 8 on the left, so I would make that 4. And then my oxygens, I have 3 times 2, which is 6. And 4 times 1, which is 4, and 6 plus 4 is 10. So I need 10 on this side, which is tricky because I have 1 here. And so if I put 10 here, I would actually have 11. So this is a bit of a tricky one. What I could do though is I would need 9 oxygens right here. So if I put a 4.5, that would give me 9 here plus 1 more, which would be 10. So it would be balanced, but I can't really have 4.5. So what I'm going to do is I'm going to multiply all my coefficients by 2, and then it will be balanced. So that 1 becomes a 2, that 4.5 becomes a 9, this 3 becomes a 6, and this 4 becomes an 8. And now it's balanced. So the term, remember, for those big red numbers are called coefficients. I hope you have those in your notes somewhere. If not, go ahead and write it in now. These small numbers down here, so like your 3 and your 8 and your 2, and this 2 and this 2, those are all called subscripts. And they tell us how many atoms are in that particular compound. The coefficients tell us how many of that molecule there are. Subscripts tell us how many of an atom is in the molecule. Okay, and then you have each of these compounds. I'm going to clear this up a little bit. Get this out of here. Each of these specific substances is called a species. So you have 4 species in this reaction. You have 2 reactant species, isopropyl alcohol and oxygen, and those are separated by the plus sign. And you have 2 product species, carbon dioxide and water. So each one of those is called a species. And the coefficient only applies to the species it's directly in front of. So this 6 only applies to carbon and the oxygen. Then it stops at that plus sign. So that's good for now. Thank you for watching. Have a great day.